All right, so this is question number 1 from the 2022 AP Calculus AB exam. It's a calculator question, and it's one of the rate FRQs where they give you a function that represents a rate of something. So from 5 a.m. to 10 a.m., we have vehicles arriving at a certain toll plaza, and the rate at which they do that is given by A of t, this function here. T is the number of hours after 5 a.m., and A is measured in vehicles per hour. It says we have no vehicles waiting in line in the toll plaza when the problem begins at 5 a.m. So it wants us to write, but not evaluate, an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m., and they even tell you that's t equals 1, to 10 a.m., which is t equals 5. So to find a total number, all you have to do is integrate the rate, and they've given us your t values from 1 to 5. You don't even have to rewrite a of t. You could just write of a of t dt, and that is all they're looking for in part A. So that's one very easy point to get on this question. In part B, they want us to find the average value of the rate in vehicles per hour at which the vehicles arrive from t equals 1 to t equals 5. Well, if we have the function that represents the rate to find its average, we just use the mean value theorem for integrals. So we're going to do 1 over 5 minus 1 times the integral from 1 to 5 of a of t dt. That math statement there earns you the first point. And then they actually do want an answer this time. So we'll go ahead and we'll plug this in to our calculator. So we have 1/4 out in front, 1 over 5 minus 1. And we're going to do the integral, which is math. And it's option number 9 down here. Option number 9 gives us our integral. We're going to integrate from 1 to 5. And we're going to put in our function a of t. And our function for a of t was 450 times the square root of the sine of 0.62t. We'll use x here. And then we'll just throw our dx on there at the end. And looks like when we have our calculator evaluate that, we should get 375.537 when we round it. So we'll say 375.537 here. And it doesn't ask for units, but we could, if we want to, we could add any vehicles per hour, since that's what our units are, just in case you came across a problem similar to this that did ask it, right? It's about an average of 375.537 vehicles per hour. Oh, and for that's our second point there. So we got 3 total points so far from parts A and B. For part C, it wants to know, is the rate at which the vehicles arrive at t equals 1 increasing or decreasing? So our function that represents the rate is a of t. We want to know if that function is increasing or decreasing at t equals 1. So to determine if a function is increasing or decreasing at t equals 1, we just find the derivative of it at 1. And since our calculator can do this for us, and this is a calculator question, we'll just go to our calculator and have it evaluate our derivative at 1. So we'll do math, option number 8 this time. We're going to do a derivative with respect to x of 450, and it's the square root of the sine of 0.62x. And we want to evaluate this when x is equal to 1. And that gives us a positive 148.947. And all we need to do here is indicate that since that value is positive, we'll say that it's greater than 0. Since a prime of 1 is positive, the rate the vehicles are arriving at 6 a.m. is increasing. And that would be sufficient to earn you both points for this part of the problem. You get 1 for considering a prime of 1 and 1 point for your answer that it is increasing because that derivative is positive. So we got 5 points here between parts A, B, and C, which means that our final part D, is going to be worth 4 points. And now we're getting a little bit more complicated. We've got a line that is forming whenever A of t is greater than or equal to 400. And it says that the number of vehicles in line at time t for t between A and 4, right, is given by this integral. N of t is equal to the integral from A to t of A of x minus 400. And importantly, A is the time when the line first begins to form. We want to find the greatest number of vehicles in line at the toll plaza, or the maximum number of vehicles in this line on this interval. So N of t here, and N of t tells us the number of vehicles in line. We want the maximum of N of t. So in order to find the maximum of any function, we first need to take its derivative and check for critical values. So we're going to find N prime of t to begin with. And the value here that we've got is we've got a derivative of an integral from some constant a to t of a function. Well, that's the first part of the fundamental theorem of calculus. It says if you take the derivative of an integral from a constant to a variable of a function, you just get the function in that new variable. So N prime of t should just be A of t minus 400. Right? And we're going to then, to find the critical values, set that equal to 0. And so that right there gives us our first point if we just consider when N prime of t is equal to 0. The next thing we'll have to do is actually find when that's true. Luckily, we've got a calculator to do that. So what we'll do is we're just going to go to our graphing calculator, and we're going to go to our y equals, and we need to graph A of t minus 400. Well, A of t was 450 square root of the sine of 0.62 x. And we're going to then subtract the 400 from it, and we'll graph. And it looks like this. Right? We got a bunch of different, we got 4 different values we can see. But of course, we only want the t values that are between, our interval was a to 4, where a was greater than 0. So I'm just going to change my window setting here. I'm going to hit window up there in the very top row. I'm going to change my x minimum to 0 and my x maximum to 4, so that all I'm looking at is really those 2 values that I need. And so what I'll do is I'm going to then hit second and the trace button, which opens up the calculate window. And I want to find when it equals 0, so I'm looking for, well, the zeros, option number 2. And so in order to do that, we just scroll over here to the left so we can actually see our cursor and make sure it's to the left of that first x-intercept. Hit enter. And then move to the right of that x-intercept. Hit enter again. And then when it says guess, we'll hit enter again. And we can see that we get our first t value of 1.4693716. So we'll put that in. This is true when t equals 4693716. And we have another one that we're going to find right now. So we'll hit second trace. Option number 2, 0. This time we'll have to scroll for a ways to the right. And your cursor will disappear. But you can keep track down there of the x values. We'll just keep hitting the button here. And soon enough we'll be there where we can see our cursor. There's our cursor. We're now to the left of our x-intercept. We'll hit enter. We'll go to the right of our x-intercept and hit enter. And we'll hit enter one more time, and it'll give us our second value of 5977133. So we'll note that here. T is also 3.597 7133. And so getting those two values there is your second point. And then what we need to do is we need to figure out which of these is actually the maximum. Well, we can kind of eliminate t equals 1.4693716 because that was the first time that a of t minus 400 equaled 0. So that was when the line first began, right? And so when the line first began, right, right as it was beginning, there were no vehicles in the line, right? So you could go in and you could evaluate n of t at 1.4693716, but when you did that, you just get 0 because this is our a value, right? We can call this a as well. It's this lower limit. It's the first time that this was equal to 400, when a of t minus 400 was equal to 0, right? When a of t was equal to 400. So really our only options are at 3.5977133 and at t equals 4. So we'll just make a little chart here. We're going to say, here we go. We've got at t, and we'll call this n of t, right? At t equals a, we know we had 0 cars in the line. And I'll just call this one b just to make my life a little bit easier so I don't have to rewrite that number. And then we're also going to try this at 4. And so we can find n of b. It's just the integral from a to b of a of x minus 400. And so we'll use our calculator to find that value. And we'll go back to our main screen. We'll hit math. We'll hit option 9 down here. And we want from A to B. So that was 1.4693713, I believe. Let's check on that value just to make sure I haven't lost my mind. 3716, good thing we checked. Not that that's probably going to make much of a difference. We'll put in our 6 there. And then our upper limit here was 3.5977133. And we're just integrating that a of x minus 400 function. Well, we might note that we actually had that stored up here, a of x minus 400, as our y1. So what we can do is, once we get back into here, to our actual integrand, instead of retyping that whole function again, which we can do, you can also just hit VARS right next to the clear button. And if you go over to the second column, y VARS, and choose option 1 for function, you can see your list of functions. And so our function is saved as y1. So I'm just going to put in y1 there, and I don't have to retype it. y1 was in terms of x, so we'll do our integral dx. And it gives us 71.254. I'm just going to round to 3 decimals now. So this is 71.254. And we'll do the same thing with 4. And, as long as we're confident that we've typed everything in correctly, we can just scroll back up on our calculator to the integral we just did and hit enter again. It'll populate the whole thing back down, and all we have to do is change our upper limit to a 4, right? Because our lower limit stays the same and the function stays the same. And now we'll get 62.338. So we'll put that here, 62.338. I guess I should have written the 71.254 here. And n of 4 was equal to 62.338. And so we could see we only had 3 options for the max could occur. It could occur at A, B, or at 4. Well, the largest value was 71.254. So to answer the question, to the nearest whole number, the greatest number of vehicles in the line is 71. So we'll say the greatest number of vehicles in line is 71. And it doesn't necessarily ask us when that occurs. And our justification is just this nice chart over here with us testing all the values, right, with indicating what the chart is of. And I guess I didn't need to put a 1 in both those spots. Right? Just the chart with the work here is 1, and then the answer of 71 is worth the final point for this FRQ. And that is the end of this rate FRQ. All right, so this is question number 1 from the 2023 AP Calculus AB exam, and it's what I call a rate FRQ again. And what we've got here is a chart of values where we've got T and F of T measured in seconds and F of T measured in gallons per second. And it's about a customer pumping gas at a gas station into their car. And so they're telling us that the rate of flow of the gasoline is measured by F of T, which is gallons per second. And what they first want us to do is just using correct units, interpret what the meaning of the integral from 60 to 135 of f of t dt is in the context of the problem. So the integral from 60 to 135 here of f of t dt, right? When we integrate a rate, we get an amount, right? So this integral is the gallons of gas pumped into the tank. And we want to specify that it is from t equals 60 seconds to t equals 135 seconds, right? So we want to make sure we've got those units in there because it says using correct units, right? So 60 to 135 seconds, and it's a total number of gallons of gas pumped into the tank. Be careful not to say it's that it's the number of gallons in the tank, right? It's not how much is in the tank during that time period, it's how much is pumped into the tank. All right, so that's worth 1 point right there, just the explanation there. And then we're going to get the rest of our points from doing the second part of it, which says use a right-Riemann sum with 3 subintervals from 60 to 90, 90 to 120, and 120 to 135 to approximate that value. So because these are not all equal subintervals, we're just going to use the regular area formula for a trapezoid. So what we're going to do is we're going to add the heights at 60 and at 90, right, which are going to be 0.1 and 0.15. So we'll do 0.1 plus 0.15. Oh, sorry, it says a right Riemann sum. I was going to do a trapezoidal sum here. So we're going to do a right Riemann sum here. So if we're doing it from 60 to 90, the first interval is from 60 to 90, and so that right endpoint has a y value or an f of t value of 0.15. So we're going to do 0.15 here times the length of that interval from 60 to 90, right, which is 30. And then we're going to add to that the next right endpoint, which is 0.1. And we're going to do that one also times 30 because it's 120 minus 90. And then we're going to do 0.05 times 15 because that's our last right endpoint of the subintervals. And the distance from 120 to 135 is 15. And so you've got a calculator. You can total these all together if you want to using your calculator. I'm not going to go through putting it into the calculator itself, but it comes out to be 8.25. And if you choose to write out things like f of 90 times 90 minus 60 plus f of 120 times 120 minus 90, you can write all of those out, but this answer is sufficient to give you both the second and the third points, right? So we got 3 points here for part A. in part B, it asks us if it's guaranteed that there's going to be a value C between 60 and 120 such that f prime of C is equal to 0. And so what we want to do here is think about what this is asking. It's asking us if the derivative is equal to 0, which when they ask you, is there a derivative equal to some value, then usually we're going to think about using the mean value theorem first. And since they've given us the interval from 60 to 120, first let's just check and see if the mean value theorem applies. Well, our function is differentiable. So we want to make a statement that says because f is differentiable, which implies continuity, the MVT applies, right? So we have a function that is differentiable and continuous, which means that the mean value theorem does apply. So now we're just going to check and see if what we need to see is, does f of 120 minus f of 60 divided by 120 minus 60 equal 0? Because we want to know, does f prime equal 0? And f of 120 and f of 60 are both 0.1. So we have 0.1 minus 0.1 over 60, which just gives us 0. And so we could say, yes, by the MVT, by the mean value theorem, f prime of C equals 0 on the interval between 60 and 120, somewhere, right? Because the function is continuous and differentiable, and its average rate of change was 0 on that interval. So its instantaneous rate of change must have been 0 somewhere on the interval. And you could have also called this Rolle's theorem, right? Remember that when it equals 0, Rolle's theorem is the special case of the mean value theorem. So that would be acceptable also, calling it Rolle's theorem. All right, for part C, we've got a new function, g of t, that models the rate of flow of the gasoline from 0 to 150. We want to find the average rate of flow. Well, this function represents the rate of flow. G of t is the rate of flow. So to find the average rate of flow, we just need to use the mean value theorem for integrals, which means we're going to do 1 over b minus a times the integral from a to b of g of t. And you don't need to go ahead and rewrite g of t all the way out. If you just write this, followed by an answer, since this is a calculator problem, that'll be perfectly valid for getting all the points for this part. And I forgot to talk about the points for the last one, so let's go back real quick and do that before we punch this into our calculator. Showing that this was equal to 0 was 1, and then having an answer with the justification up here that it was differentiable and continuous gives us our second point. Okay, so now back to this one. So now we're just going to punch that into our calculator. So we're going to get our calculator here. We're going to do, I'm going to get this little fraction here. 1 over 150 minus 0 is just 150. Right? And so then we're going to do math. And we're going to go down to option number 9, FNINT. So we have 1 over 150 times the integral from 0 to 150 of our function. Right? We're going to write our function in terms of x. So our function is, first off, x over 500. And then we're going to multiply that by the cosine of x over 120 squared. So I'm going to put that into a new parenthesis here. We're going to have x over 120 squared, all of that inside of our cosine. And then we are seemingly missing another parenthesis there. Now we should have enough parentheses for it all to match up. We'll put our dx there. And when we calculate that out, we should get 0.09599666962, which you can round to 3 decimals. We'll call it 0.096. And nowhere in here does it ask us anything about units, so we don't need to worry about units. We would have gotten 1 point for the correct setup and 1 point for the correct final answer. All right, now for part D, we're using that same model for G to find G prime of 140, and then we're going to interpret the meaning of our answer. So even if you don't know what it means, which we should be able to figure that out, but even if we don't, we could still find G prime of 140. We're just going to go into our calculator, and we're going to have it take the derivative for us. So we're going to write G prime of 140 is approximately equal to, we'll just go in here, and we'll say math, and we're going to, this time we're going to go down to option number 8 for the derivative. And we want the derivative with respect to x of our function. Right? And our function, once again, here was, I'm going to put a new parenthesis here, it's x. Let's fix that. We're going to have an x up here. And in the denominator there, we're going to have a 500. And then that's being multiplied by the cosine of, and then we're going to throw some more parentheses in here. We're going to say x over 120. We'll close that first parenthesis and we'll square it. And then we'll close the second parenthesis. And we wanted to evaluate this when x was equal to 140. So we'll just type in 140 for where we're evaluating. And we should get an answer of negative 0.0049, which we'll call negative 0.005. And it doesn't ask us for units here, I don't believe. It just says interpret the meaning of our answer, but it's still always nice to put the units just for good practice. So the interpretation of this is going to be, we've taken the derivative of G. Well, G measures the rate of change. So a negative 0.005 is going to tell us that the rate of change of gas pumped into tank is decreasing, because that's a negative value, at 0.005. And our units here are gallons per second, if we want to throw our units on there. And we'll indicate that this is at t equals 140 seconds. We want to have all those things in there because they want us to be specific about what's happening, right? It's the rate of change is decreasing, right? It's not that the rate, or it's not that the amount is decreasing, but it's that the rate of change is decreasing because G represents the rate of change. And so its derivative tells you if it's increasing or decreasing. And you get 2 points here for this one, 1 point for the value, and 1 point for the explanation. And that is the end of that FRQ. All right, so this is question number 3 from the 2025 AP Calculus AB exam. It's what I consider a rate FRQ, where they give you some situation where they've given you a rate, right? And so in this one, we have a student who's reading a book at time starting at t equals 0 minutes and reads for 10 minutes. And it gives us a rate at which the student is reading in words per minute. And so they give us a chart in this case. And it's not always a chart. Sometimes it's just a function. But for this one, they give us a chart that says that, hey, at t equals 0, 2, 8, and 10 minutes, here is his rate of words per minute that he is reading. And so what we want to do first, which is fairly common here, is to approximate capital R prime of 1 using, and they even tell you how to do it, using the average rate of change of R over the interval from 0 to 2 and use correct units. So this should be really easy. R prime of 1 is going to be approximately equal to, like they said to do, the average rate of change, which just means the slope between 2 and 0. So you're just going to do 100 minus 90 over 2 minus 0, which is 10 over 2, or 5. And then our units, right? If R was already in words per minute, this is going to be words per minute. But we've basically gone down one level, right? We've approximated the derivative, so it's words per minute. In fact, we'll just write per minute here. Words per minute per minute. And those are our correct units, and that's actually worth 2 points. One for having the correct setup here with an answer of 5, and 1 for the units. So we got 2 points there for part A. In part B, it says, must there be a value C between 0 and 10 such that R of C is equal to 155? Right? And so now we have to kind of think about what they're asking us here. They're saying, is it guaranteed that there's a time when he was reading 155 words per minute? And it tells us that this function is a differentiable function. And so we might look in our chart and say, oh yeah, R must have equaled 155 because it went from 150 to 162. And the intermediate value theorem is what would tell us that, right? If our function was continuous on this interval, then yeah, between 8 and 10, we must have hit 155 because we must have gone from 150 to 162. The key point here is that you need to make the statement that because R is differentiable, and you need to say this, you need to write this on your paper somewhere, because R is differentiable, R is continuous. And so then you can say, so intermediate value theorem applies. And since the intermediate value theorem applies, now you can say that R of 8 was 150, which is less than 155, and that R of 10 was 162, which is greater than 155. And so you can say, by the intermediate value theorem, R of C must have equaled 155 on the interval 8 to 10, which is, and you can say, which is a subset of the interval 0 to 10, which is what it was asking you about. Or you could have just said, you know, right here, instead of saying R of 8 was 150, you could have said, oh, R of 0 was 90, and 90 is less than 155. And then you can just say on 0 to 10 here, without having to classify that 8 to 10 was between 0 and 10. Okay? And it's always good to make sure you apply the correct theorem here and state that you're using the intermediate value theorem. So we got 2 points for this. One is stating that it's continuous because it's differentiable, and the other is yes, right here, right? Yes, it must equal 155 with an explanation. All right, for part C here, it asks us to use a trapezoidal sum with 3 subintervals to approximate the value of the integral from 0 to 10 of R of t. So we're just going to, since we don't have equal subintervals, 0 to 2, 2 to 8, and 8 to 10 are not equal, all we can do is just do a setup here of 3 separate trapezoids. So you can just go right ahead and say 90 plus 100 divided by 2, because that's the average of the 2 bases, right? The first and the second y values. And then multiply it by 2, the width from 0 to 2. And then we're going to add to that 100 plus 150 divided by 2 times that next width of 6 from 2 to 8. And then we'll add to that 162 plus 150, right, these last two, divided by 2 times the width here from 8 to 10 of 2. Okay. And if you look in the scoring guidelines, they say things like r of 2 plus r of 0 divided by 2 times 2 minus 0. And then they say r of 8 minus r of 2 divided by 2 times 150 minus 100. Oh, sorry, times times 8 minus 2. Not 150 minus 100, times 8 minus 2. And you don't really need to show all of that out. All you really need to do is show, if you do this step correctly, you're going to earn that first point for showing the form of the trapezoidal sum, right? And so, you don't necessarily have to write it out in the notation that they are showing in the scoring guidelines. So here we have 90 plus 100 divided by 2. Well, 90 plus 100 divided by 2, and then times 2 is just going to be 190. And then 100 plus 150 divided by 2, and then times 6. Well, that's just like 250 times 3, so that's going to be 750. And then 162 plus 150 divided by 2 times 2 is just going to be 312. Add those all together and you get 1,252 as your answer. So you're getting, you're getting 1 point for the having the correct form up here, and you're getting 1 point for your answer. So 2 points there in part C. And here in part D, we've added something in. We've got a teacher that's now also reading for 10 minutes. And we're given a different function to represent their rate, w of t, which is -3/10 t squared plus 8t plus 100. And we want to know, based on this model given to us, how many words has the teacher read at the end of 10 minutes? Well, if we're given the rate at which they've read these words in words per minute, we just have to integrate that rate to get the amount. So we're going to integrate w of t dt from 0 to 10. And this is sufficient right here for getting your first point already, just writing that. And then actually doing the integral correctly gives you the next point. So if you integrate -3/10 t squared, that goes up to -3/10 t cubed divided by 3. So that's -1/10 t cubed. The 8t will become plus 4t squared, and the 100 will become plus 100t. And we're going to evaluate that from 0 to 10. And you get a second point there for just correctly taking that antiderivative, -1/10 t cubed plus 4t squared plus 100t. And then we'll evaluate it from 0 to 10. So t cubed when t is 10 is going to be 1,000, but we're going to divide by 10. With a negative out in front, that'll be -100. And then we'll have plus 4 times t squared, or plus 400. And then we'll have plus 1,000 there. And then, of course, at the end, it's all just minus 0, because if I plug 0 into each of those 3 pieces, we get 0. And so, I said 1,000 there, but I didn't write that last 0. So we got 1,000 there. And so we have -100 plus 400 is 300 plus another 1,000 is 1,300 words. Okay? And so that's how many words that teacher has read at the end of the 10 minutes. And that answer will get you your third point for part D, and that's the 9 total points for this question here from the 2025 exam.